Alright, so let's look at this problem. Told that a commercial bleach solution contains 3.62 mass percent sodium hypochlorite in water, and I'm asked to calculate both the mole fraction and the molality of the sodium hypochlorite in the solution. Alright, so let's write down what we know in our given. 3.62% sodium hypochlorite in water. And I'm asked to, in the first part, calculate the mole fraction. What is the mole fraction? The mole fraction here is going to be the moles of the sodium hypochlorite over the total moles of the solution. Since there's only two components, it would be the moles of the sodium hypochlorite plus the moles of water. Do I have enough information to calculate that the moles of sodium hypochlorite and the moles of water? Well, if we assume that I have 100 grams, that's not a bad assumption, by the way, to solve problems if you're given a mass percentage. See if it gets you anywhere if you assume that. But if I assume I have 100 grams, then I know that I have 3.62 grams of the sodium hypochlorite. That can get me to moles. I know there's only two components, so I know that there's going to be 100 minus 3.62 moles of, grams of water. Okay, so that gives me 96.38 grams of water. From this information, can I get moles of both of those? Yes. So let's go ahead and do that. So I know grams of sodium hypochlorite in 1 mole of sodium hypochlorite. And if you notice, I use labels on things because I'm doing, in these problems, solution problems, there's moles of solute, moles of solution, moles of solvent, masses of different things. So it helps to label things just so that you know what it is you're talking about. Okay, so calculating molar mass of the sodium hypochlorite, I get 74.443. Doing that calculation, I get the number of moles as 0.048628 moles sodium hypochlorite. Notice that I carry more significant figures than I need to. My given in the problem only has 3. I know that I'm going to round my final answer to 3, so I'm going to carry more throughout. So my X of my sodium hypochlorite is going to be equal to 0.044628 over 0.044628 plus 5.3485. And that oh, I'm sorry, I copied this number down wrong. It's just 48. Okay. 8628. And I end up with a mole fraction of 0.00901. Okay, So now the second half, I need a new page, is to calculate the molality of the sodium hypochlorite in the solution. All right, well, what is molality? Molality is the moles of solute. In this case, it will be the moles of sodium hypochlorite over kilograms of the solvent. Okay, well, from the previous problem, I know that the moles of the solute was 0.048628 moles of my sodium hypochlorite over the kilograms of solvent. Well, my kilograms of solvent was the 100 minus the 362, which was 96.38 grams, but I need that in kilograms, and I know that there are 100 grams in 1 kilogram. So I can do this math. 0.048628 divided by 96.38 times 1,000. And I get 0.505 molality sodium hypochlorite. Okay, and that should be both of those problems.